Hello, I'm Mrs. Jacobson, and today we're going to cover section 3.3, piecewise and power functions. A piecewise function is when it's broken into parts, and what you're doing is first deciding where x falls. So if x is less than or equal to 3, you use this function, just the value 3. And if it's greater than 3, we use this. So the first thing we look at is 0, because that's f of x. X is 0. Well, 0 would fall into this one because 0 is less than or equal to 3. It's not greater than 3. So our answer is 3. When it equals just a value, it's a constant. Looking at 3, equal to 3 would be this one because this does not have the equal to with it. And since it's a function, it will only have one or the other. So 3 would also use this one, and our answer would be 3. Well, the last one we're plugging in a 10. 10 is greater than 3, so that falls into this one. And we'd plug it in. 2 times 10 minus 1. 19. So you're just deciding where it falls. F of negative 1 would be less than or equal to 3, so it's 3. F of 4. 4 is greater than 3, so it falls into this one. 2 times 4 minus 1 is 7. Let's try another one. This one is x less than or equal to 0 and x greater than 0. So first look, we have a negative 1. Which one does it fall into? Well, this one, because negative 1 is less than or equal to 0. Negative 1 is not greater than 0, so it's the top one. We're plugging in negative 1 squared plus 5, which is 6. Next one, you're plugging in 0. If we plug 0 in here, 0 is less than or equal to 0. Doesn't work here. 0 is not greater than 0. It needs the equal to. So again, we use the top one. 0 squared plus 5 is 5. Last one I put here was 1. 1 is not less than or equal to 0. It is greater than 0, so it would use the bottom one. 1 cubed minus 1 is 0. Okay, let's try a couple of the story problems. Number 43. Here we go. And this is on page 208. For the non-extreme weather months, Palmetto Electric charges $7.10 plus 6.747 cents per kilowatt hour for customers using up to 1,200 kilowatt hours and charges 88.06 plus 5.788 cents per kilowatt hour above 1,200 for customers using more than 1,200 kilowatt hours. And so the first thing they want to do is write a function that gives the monthly charge in dollars as a function of kilowatt hours. So cost kilowatt hours. And they told us that for customers using up to 1,200 kilowatt hours. So when, let me leave some space, if x is less than 1,200 kilowatt hours, because it says up to. The other one says if they're using above 1,200 for customers using more than 1,200. More than 1,200. Customers using up to this. Okay, so let's read it again. For the non-extreme weather months, they charge $7.10, $7.10 plus 6.747 kilowatt hour. Move this up a little bit so you could see both. Now for the other group, someone's using up to 1,200 kilowatt hours and charges 88.06 plus 5.788. Oh, this is in cents. Since it is in cents, we need to move 2 decimal places. Because the one is in dollars, the other's in cents. There we go. So make sure units are the same. Since this is dollars, this was cents, I had to move the decimal over too. So this was above 1,200. So above 1,200, that means the 1,200 is in this one. There's a little word here, above 1,200. So when it's 1,200, you use the lower one. Write a function that gives the monthly charges. So that's what we did in dollars, and we converted our cents to dollars. What is the monthly charge for 960 kilowatt hours? So if 960 kilowatt hours, 960 would be the less than, so we're using this one. And we plug that into our calculator. 7.1 plus 0.06747 times 960. $71.87. $960 kilowatt hours would cost $71.87. What is a monthly charge for 1,580 kilowatt hours? So 1580 would use this one because it's larger than 1,200. So we're already starting out at $88 plus 0.05788 times the 1,580. $179.51. Okay. Try one more. Number 45. The first class postage charged for a letter in a large envelope is a function of its weight. The U.S. Postal Service uses the following table to describe the rates for 2015. weight increment in ounces, first class postage. So first ounce or fraction of an ounce. So from 0 to 1 ounce, it's 98 cents. After that, each additional ounce or fraction in between there is 21 cents more. So you pay the 98, and then if you go over an ounce, a little bit over, 98 plus 21. Convert this table to a piecewise function that describes first-class postage letters weighing up to 4 ounces. Use X as the weight in ounces and P as the postage in cents. So P of X equals well, we might need more than that because we're going 0 to 1 ounce. And then we're going from 1 to 2. To 3. Each additional ounce is including in this one. Once you go over that ounce, then you pay the next fee. And so that would be your if parts to find out which value to use. Now for the first one, convert this table, weight in increments of X. Okay, so if it's between 0 and 1, did it say cents or dollars? Cents. It would be 98 cents. Well, it's in cents. And then if it's between 1 and 2, it goes up 21 cents. So that would be 119. All I did was take the 98 plus 21. And then it's another 21 cents if you're between the 2 and up to and including 3. So you add another 21 cents and get 140 cents. And another 21, 161 cents. So depending on where you land, this is what you'll cost. But they wanted it in cents, so we'll leave it in cents and not convert it to dollars. Find 1.2 and explain what that means. $1.2 falls in the second one because 1.2 is between 1 and 2. So it would be 119. What that means is if the mail envelope weighs 1.2 ounces, the cost is 119 cents. Give the domain of P as it is defined above. So the domain of P, that's your function values. Well, no, the domain of CX. So for the function, the domain is between 0 and 4. So it's 0 to 4. Oops. And it's including the endpoint, so you would have square brackets. Well, it wouldn't make sense to have postage that's 0. So they probably wouldn't include the 0. Let's see how they wrote it. A fraction of an ounce up to an ounce. So it would not be including the 0, but it is including the 4. They don't ask it, but let's list the range. The range is not continuous, whereas this is getting all the decimals in between. This is not. So the range would only be these values. You'd use a set notation, 98, 119, 140, and 161. And so since they are not, it's not continuous, you just list the points and you use a set notation. Main P of 2 and P of 2.01. Okay, P of 2. 2 falls in this one because from 1 up to and including 2, it's 119 cents, which is what we found up there. But when we do that 1 ounce over, it puts us here, not even an ounce, 0.01, a hundredth of an ounce. It gives us $140. Find each. So the P of 2 is 119. If we go a little bit over, it drops it into the next value, and so it costs 140 cents. Find the postage for a 2 ounce. Okay, that's the same thing we did. They want you to understand that those two things mean the same thing. That when we plugged it in, that told us if we have a 2 ounce letter, it's 119 cents, but if we go a little bit over, it's 140 cents. And that might not matter when you're sending one envelope, but if you're sending 300 wedding invitations, that extra makes a lot of difference. Okay. If you have any questions, let me know.